we have to figure out the length of the longest substring which doesn't have any repeating characters. To do this, we create an array last which contains 256 elements corresponding to the 256 elements in the ASCII table. We initialize all elements of the array last to the value -1. It's important to remember here that the array last indicates the last index at which that particular element occurred in the string considered so far. Let's take an example over here. So the last of A is 2. This means that A occurred last at the second index in the string considered so far. Let's consider the string S whose substring we have to find. We assign last of S of 0 as 0. Over here, S of 0 represents the first element of the string. It occurs at the 0th index. So as we can see, last array stores the last occurrence of that particular character. Over here, S of 0 is the character and 0 is the index. We initialize maximum underscore L and current underscore L as 1. Maximum underscore L indicates the length of the maximum non-repeating substring achieved so far. Current underscore L, on the other hand, stores the length of the current substring being considered. We have assigned values 1 because we have only considered the first elements till now. Next, we start scanning the string S iteratively, starting from the second element using the index I and considering the following cases. It's important to remember we've already considered the first element, so we can directly skip ahead to the second element. If the element Si doesn't occur in the current substring, we increment current underscore L by 1 and include that particular element in the substring. Let's take an example over here. XABAS CUS. This is the string that we're considering. Say we're currently scanning the element B. And the current substring that we've considered so far is XA. Since B doesn't lie in the current substring, we include it to increase the length of the current substring. So now the length of the current substring is 3. And the new current substring is XAB. In the second case, the element is present in the current substring. Here, to include the currently scanned element, we're going to shorten the current substring by removing elements till the last occurrence of that element. Since the current length is going to reduce, we have to update maximum underscore L. So, if maximum underscore L is less than current underscore L, we assign the value of current underscore L to maximum underscore L. And we can change current underscore L to exclude the previous occurrence of the current element. So current underscore L is the new value of current underscore L. I is the current index that we are scanning. Last of Si denotes the last occurrence of the character Si. Si is the current character that we are scanning. I is the index that we are scanning. It's important to remember that this is a very necessary step. Let's consider a previous example. Say the current string is XAB. Now A is encountered. Since it already exists in the substring, that is, it occurs at this index, we reduce the substring to BA to include the character A. So now the length of the substring reduces to 2 and the new substring is BA. After the iterations are complete, we again update maximum underscore L as follows. If maximum underscore L is less than current underscore L, we assign the value of current underscore L to maximum underscore L. Finally, the variable maximum underscore L stores the answer, as it stores the length of the longest substring without any repeating characters.